All right, we're about to dive into a world that sounds like something straight out of science fiction. A world where sound isn't just something you hear, it's something you can see. We're gonna explore the incredible and, yeah, kinda unsettling tech that can visualize everything from a song to a whispered secret. Let's get into it.
So I want you to imagine this. You're in a completely silent room. I mean, totally soundproof. No microphones, no bugs, nothing. And yet, someone outside could know the rhythm of your heartbeat or even the words you're whispering to yourself. This isn't a movie plot. It's the new reality, where every single sound leaves a visible trace on the world all around us.
So how on earth is that even possible? Well, to get it, we have to kind of rewind and rethink what sound really is. See, it's not just this invisible thing that goes into our ears. It's a physical force, a force that leaves these tiny, unseen echoes everywhere.
That's right. Every sound you make, a clap, a word, anything, it's a wave of energy that literally makes things around you tremble. That coffee cup on your desk, the leaves on a nearby plant, the glass in your window, they are all dancing to an invisible rhythm that you create. Now, for years, you needed a microphone to pick up those vibrations. But today, all you need is a camera.
You know, this whole idea of seeing sound isn't actually that new. The journey to capture it started way before we had fancy cameras and lasers. The very first attempts to give sound a visual form were, believe it or not, surprisingly beautiful. And they started all the way back in the 18th century.
The elegance of this is just stunning. A physicist named Ernst Chladni takes a metal plate, sprinkles some sand on it, and then runs a violin bow along the edge. And like magic, the sand just arranges itself into these perfect, intricate geometric patterns. This was the first time anyone had ever proved that sound isn't just noise, it's an organized force with a unique visual fingerprint for every single note.
Okay, so the next big leap comes in 1857, decades before Edison was even on the scene. An inventor, Scott de Martinville, he wasn't trying to play sound back, he just wanted to write it down. His invention, the phonotograph, basically scratched the shape of sound waves onto a cylinder, and for 150 years, that's all it was, a visual, a scratchy drawing. It wasn't until 2008 that scientists could scan those lines and finally hear it, a human voice, from an era we thought was silent. That sound was seen for a century and a half before it was ever heard.
So we've gone from drawing sound with sand to writing it with a needle. What's the next logical step? Well, how about actually photographing it? This brings us to a really revolutionary technique that can take a direct snapshot of a sound wave as it's zipping through the air.
The air all around us. It isn't empty, right? It's full of molecules. And when a sound wave travels through it, it squishes some of those molecules together and pulls others apart. It actually changes the air's density. Now, even though that's totally invisible to our eyes, that change in density bends light, just like a lens. The whole point of the Schliering technique is to capture that exact moment when the light bends.
So how does this brilliant little trick work? It's so clever. First, you set up a perfect field of parallel light beams. Then, a sound wave, say from a clap, goes through and bends just a tiny fraction of that light. And here's the secret sauce. A simple razor blade, placed in the perfect spot. It acts like a gatekeeper. It lets all the straight, unbent light pass right by, but it blocks the tiny little bit that was bent by the sound. That block light creates a shadow, and that shadow is the perfect outline of the sound wave itself, frozen in an instant.
Okay, so why do we even need to take pictures of the air? Well, this technique is basically the superpower that lets engineers see the invisible. You absolutely need it to design the wings of a supersonic jet or to make your car more aerodynamic and fuel efficient. It's used to visualize shockwaves from explosions, and it can even spot dangerous invisible gas leaks. It lets us see the hidden forces that shape our world.
So while the Schlieren technique is amazing for watching sound move through the air, modern methods have taken this a giant leap forward. They've figured out how to turn pretty much any object in our world into a potential microphone.
Okay, let's break down the two main ways this works today. First up is the visual microphone. This uses a super high-speed camera and some clever AI to just watch an object. Literally anything, a houseplant, a bag of chips, and it analyzes the microscopic vibrations to rebuild the sound. Then you've got the laser microphone, which is every spy's favorite gadget. It shoots an invisible laser at a window from far away and just reads the vibrations off the glass.
And the sensitivity here is it's mind-blowing. The visual microphone can pick up on movements and vibrations that are smaller than 1/1000th of a millimeter. To put that in perspective, that's a tiny fraction of the width of a single human hair. And from those impossibly small movements, it can reconstruct entire conversations.
And here's the proof.
In this now famous MIT experiment, researchers played Mary Had a Little Lamb inside a room. In a completely separate room, behind soundproof glass, they just aimed a high-speed camera at an ordinary bag of potato chips. By only analyzing the tiny, invisible vibrations of that chip bag, their algorithm perfectly reconstructed the song. The chip bag literally became the microphone.
Of course, spies have been all over this concept for decades. Back in the Cold War, the Soviets gave the US ambassador this beautiful wooden seal. Hidden inside was a device called the Thing. It had no batteries, no power source. It was activated remotely by radio waves, which made it vibrate with the conversations in the room. And today, there's a technique called lamp phone that can listen in from hundreds of meters away just by watching the imperceptible flickering of a light bulb as it vibrates with the sounds in a room.
So when you start to connect all these dots, from Chladni's dancing sand to laser microphones watching light bulbs, you realize we're walking into a brand new era. One where the line between what is seen and what is heard is basically dissolving, and it forces us to ask some really tough questions about privacy.
And this quote, this really just nails it. For centuries, our whole concept of privacy was built on a simple idea. If you're in a quiet room behind a solid wall, your words are safe. But that whole assumption, it's crumbling. In a world where light can be used to listen, the simple absence of a microphone means absolutely nothing.
And that leaves us with a pretty profound question to chew on. We now live in a world where every sound we make leaves a physical, visible trace on everything it touches. A world where a plant, a window, or even a potato chip bag can be turned into a listening device. And this tech is only going to get better and harder to detect. So in that world, where any object can be a witness, what's a secret?
Thank you for watching.